All right, we'll get started here. Thanks for your patience. Turn down the lo-fi. Hopefully you can hear me. Good morning, Jason. How are you, sir? All right, just a quick follow-up from last week, and wanted to go over a couple things that I missed during the stream that I noticed. So we'll start there. Hope you're having a beautiful Friday. I am having a wonderful Friday, except I haven't showered yet, which is why I'm wearing a hat. All right, let's start with last week. We were going over the setup of multi-WAN or multiple internet connections with OPNSense. And if you were lucky enough, like Jason, to see my epic fail, there were a couple of issues that happened, which were kind of unforeseen. And I'm not exactly sure why they've happened, but we'll just review them real quick. So first one is, actually, let me refresh this. Okay. All right, so the first one was on our secondary gateway, our secondary internet. We had a monitor IP that was set to an IP address of 1.1.1.1. Now, normally I've used that before and it's been fine to use as a monitor against an internet connection being up or down. But for some reason, this may be being blocked because I'm also using this at my my regular router, or the router that gets me actually to the internet, not the virtual one I'm using here as a demo. So basically, because that monitor wasn't responding, the firewall itself, or in this scenario here, was basically saying, oh, well, this secondary internet's also down, so I'm not even going to use it. So if I hit save here and apply changes, we'll see in a second, if we kind of refresh here, it responds, but then after a certain amount of time, we'll see this, this goes down here in a second. So that was the first issue. That's why the failover didn't work. So the fix to that was just change it to one of the Google IP addresses, 8.8.4.4. Now, with the monitor IPs, you can only use one IP at a time. So we can't put like 8.8.8 that we're using here in this primary internet connection for the monitor IP on the secondary, because OPNSense doesn't like that. You have to monitor two different locations, because technically it could be the location you're using to monitor that's down, causing your firewall to fail. So it forces you to use two different IP addresses. Okay, now the second issue, and let me re-enable this first internet connection here, if I can get my system to respond. Okay, so we'll put that back on. Let's go ahead and just refresh this. Now our primary one is back. You'll notice here that there are actually no metrics, and this was evident last week if you had a keen eye. This one was monitoring, but this one was not. And that's because I forgot, when you set up one of these OPNSense firewalls initially and it uses DHCP, by default it actually checks this box right here, disable gateway monitoring. Even though we had an IP address in here, this was checked, which is why we weren't getting any statistics in the monitoring. So if we hit apply changes and give it a second, we should see, now we see some metrics coming back, which is useful, especially if you were to do some more advanced monitoring, where in the group, we come in here and go to edit, there are different things we can do with our internet connection. Let's say, for example, we have a primary and all of a sudden, for whatever reason, there's a certain amount of packet loss, like there's something wrong on the connection. So it's not like it's down, but there is some data being lost. We can tell the failover to say, okay, if it's above a certain threshold, let's say above 5% packet loss, then switch over, right? And it'll continue to monitor it. And if it comes back to normal, it'll switch back. Same with latency. Latency, if you're not familiar with network stuff, is that's the amount of time it takes for a packet of data to go out to your destination and come back. So it's measured in milliseconds. And if we come back here to our single gateway, we can see both of these have 0 packet loss, okay, which was the first thing we talked about. And then the round trip, you know what? I don't know the difference between RTT and RTTD. Maybe Jason has some insight into that. But basically, these are measures of what are called latency. So the amount of time that data is traveling to and from your firewall, or from and back to your firewall. And so you can actually configure your gateway group to trigger a failover based on those kind of metrics. All right. So anyway, that was fun last week. And, as I was reflecting on that demo last week, I realized there may be some folks interested in this stream that really don't know what I'm talking about on the network side. And my philosophy in learning anything about IT, and therefore sharing the knowledge that I have, is I always like to try to understand things at a very base level. And so what I thought I'd do this week is kind of take a step back. And, if you're a network person watching this at the moment, this might be a little beneath you, or you may be already familiar with some of these concepts, but I think if you're okay with it and you could actually help out, what I'd like to do is start at the beginning and talk about why any of this really matters. If you're a small business or you're a home user, one of the most important things, in my opinion, and this kind of gets into the philosophical underpinnings of why I got into IT, is that you want to be as self-sufficient as you can when it comes to technology. Today technology is becoming this, it's very complicated at times, and it's becoming this thing that the experts are the only ones that know anything about. And so you have this move to a centralized cloud environment where all of the underpinnings, or how things work, has become this very difficult thing to understand. And as things get centralized and power gets centralized, you are going to want to equip yourself with enough knowledge to decouple yourself from that kind of environment. And when it comes to hosting or self-hosting, or kind of gaining control back over your sovereignty, or your digital sovereignty, understanding networking at a certain level is very important, because it's kind of the underpinning of technology. Everything is connected. And so you want to make sure that you can build out a system, whether it's in your home or your business, that helps you to be somewhat disconnected in a manner from that public centralized cloud. So what I thought I'd do is spend a few minutes, maybe just the rest of this live stream, kind of starting at the beginning and sort of designing or talking through what makes up a network, and kind of creating a scenario that might be relevant to you, where we can actually design our own network together. And so I have a program called Draw, which I know a lot of folks are familiar with. It's a great diagramming program. If you haven't used it or downloaded it or installed it, I highly recommend it. It's a Microsoft Visio alternative, and it's very functional and works very well. And so um, what I'd like to do is let's define what it is we need on our network. So obviously we have maybe let's use our home as an example. So we've got a laptop and we've got some devices, and maybe when our friends come over, we let them connect to our Wi-Fi, and so we've got sort of these outsiders coming into our network that need access so that they can use the internet. And then maybe we have something that we're hosting, like let's say we have some a next cloud instance or something like that, where we're hosting our own files and sharing them with family and friends and that kind of stuff. And so what should our network look like if we have this kind of environment? Well, let's start with our, we'll be very rudimentary in our drawing because don't have a whole lot of time. So we'll use this. This is going to be our internet. So let's say that's, just so I don't get sued, we'll say, oops. We'll say this is we'll just call it Mervisen. That's our internet. And then we have, we'll just use stick figure drawings here. So the internet comes into our Mervisen router, okay? Now, at this point, your provider, Mervisen, is in complete control of obviously your internet connection and this device. Even if you change the password, they still technically can support you, which means they have full access to the device. And in fact, if you log into your Mervisen account, most likely you can control your Mervisen router. It's going to be funny. From your cloud account, right? So you can see the settings, you can change the password, you can see all, which means that Mervisen themselves, they also have direct access into your network. So if you're using their router, then anything behind this, okay, they will have direct access to. So like maybe TVs or devices or smart TVs or whatever, okay? And so what you should do, or what you should think about doing, is saying, okay, Mervisen, spell that right. I am going to put a buffer in here, and I'm going to use my firewall. Okay. Now, a firewall and a router are very similar. So a router is just a device that takes traffic from one network and then routes it to another network. Okay. A firewall, it adds some things to a router that includes certain things such as allowing or disallowing certain types of traffic to be routed from one network to another. Firewalls can often also have capability to actually maybe allow traffic, but while it allows it, to inspect it to see if inside of that traffic there's something malicious. So the difference between a firewall and a router is a firewall is a router, but it's much more than a router, okay? And Mervisen's router is going to come with some basic traffic management, so it'll disallow or allow certain types of traffic, but most likely it's not going to come with a whole lot of these other features where it's actually checking for viruses or looking for intrusions and that kind of stuff, which is why if you care about your internal network, you're going to want something in between Mervisen's internet and their router, so that as the traffic passes through, you can yeah, that's a good idea, Jason, in terms of the internet being isolated. So talk about that. So anyway, we're going to put our own router / firewall in between, and that's what this is. Okay. Whoops. So our OPNSense firewall in our scenario, and it could be anything. It could be a Sonic wall or a PFSense, or I don't know. There's a ton of them out there. Whichever one you're comfortable with. I like OPNSense because I agree with their philosophical approach, and it's a good product. And it's free, except for your time and knowledge and understanding. But it also has the other nice thing about it. It has some nice paid features that give you an extra layer of security for like business purposes, or even personal. If you're working from home or you actually have a home business, I would treat your environment as a business environment. Okay, so now we have our firewall in here. Okay, and let's talk a little bit about our Wi-Fi. And for that, we'll use an ellipse, I guess. Okay, we have our internal Wi-Fi. I highly recommend we segment out our guest Wi-Fi. Okay, let's do our guest Wi-Fi. We'll just call it our internal Wi-Fi. Okay. Now, we also have our LAN, or let's talk about like smart devices, because everybody likes smart homes. Smart devices are notorious for, oops, sorry about the bump there, are notorious for having vulnerabilities in them, meaning they open up ports to the internet. You know, depending on the device, it probably has some sort of built-in like spying capability. Technically, that's what they're for. It doesn't matter who the country is that built it. And so that's definitely, those devices are definitely something we would want to isolate from our laptop or our desktop that we have in the office, because we don't want traffic coming from those devices and scanning our network and then reporting out to its master what's going on, or even opening up back doors into those environments. So we're also going to recommend, now we could put that on the guest Wi-Fi, but let's isolate that out. So we're just going to call this smart devices. I need to come up with a good euphemism for smart devices. Yeah, Zen Armor, good one. And so we'll put that one off to the side here. Now, I know this seems to be getting a little complicated, but let's say we have a server, a little server, that we use to host certain things in the environment. We want to separate that network as well for a couple of reasons. One, we certainly don't want the smart devices having direct access to that. So we want to control traffic to and from the smart devices network and our server and these other networks. And we probably don't necessarily want our guests to have direct access to that same equipment. Maybe we allow certain services, like let's say we're hosting a website on this box and we want our guests to get to our website, we can allow those, but we don't want the guests necessarily to have the ability to actually ping the server or log into it or attempt to log into it. So we want to create a separate network for that environment as well. Now I'm just going to continue to use ellipses. I'll update this after. So let's call this our server network. Servers. Okay, so far we have what we would consider 4 different networks. Okay, now there's a theory where you would also potentially want to isolate your internal Wi-Fi from the internal LAN. And you know, if there's some merit to that, but in a home environment, as long as you're not mean, technically, let's say you had a Wi-Fi device, right? And it wasn't Wi-Fi, it was on the LAN. You'd still want it to do the same things that a desktop on the LAN what you would want to do. So that was not spoken properly, but you get the idea. So to me, there isn't a significant amount of benefit other than if the device itself has some sort of vulnerability in it. So that's potentially one consideration. Now, to keep things simple, so at the moment, we're just going to rename this to, instead of internal Wi-Fi, we're just going to call it the internal network. Okay. So we'll stick there, and we can discuss, if you guys have thoughts on that, Jason, if you have thoughts on that, feel free to share. But so we're going to have a guest network. We're going to have an internal network. We're going to have a network for our servers, and then we're also going to have a network for our smart devices. Okay. Now, when we say we're going to have a network, what does that actually mean? Right. So that's the next thing. What are we doing? Okay, I got 8 minutes. And so basically what we're talking about is we're talking about isolation. And there are several ways to isolate networks. One is you could put all of the things that connect to this on their own switches. And then you could, if you had a firewall that had a port for each of your let's say this had 4 ports plus 1 port for the internet, you could plug each of these switches into their own port, right? And then in the firewall, you just say, okay, this port belongs to this network, this port belongs to this network, this port belongs to that network. And that's a way that a lot of people do it. And so if you have that kind of hardware, that's the typical method. Like if you ever have logged into another firewall and it's got an optional port, or maybe it has a LAN 0, LAN 1, LAN 2, LAN 3, that's basically that concept. And that's technically how you would do it. What we're going to do, though, since we don't have all of those ports, we're going to use what are called VLANs. Okay, so think of a VLAN as like a virtual switch in a way. It's a method to isolate network traffic and create a boundary on the network, and it's a virtual, so it's in a single port. So it's like splitting a port up. We have a good example of a port here. No, all right, not gonna waste time with that. So let's say you have a port that is, we'll just use a box. Okay, let's say this is a port. Okay, and what we're gonna do is we're gonna virtually split it up into 4 different sections. So it's technically it'll look something like this. And we're gonna add another line here. Right, so think of it conceptually as taking a port, and we're gonna plug let's use this guy. Here, sorry, I'm wasting precious time. Okay, so we're going to plug this guy into here. We're going to plug this guy into here. Oops. Can't draw. Okay. And then we're going to plug this guy into here. Okay. All right. And these are going to be our virtual networks. And so, or our VLANs. Okay. So we'll call this one. And the number is not really important. It's just got to be different. And there's got to be, it's always helpful to have some sort of logic to it. So VLAN, A VLAN is a numbered segment. Okay, so we're going to label it VLAN, but the actual VLAN tag, what's called a VLAN tag, let's start with our guest Wi-Fi. We don't trust it. Actually, I'm going to save that. So we're gonna say this is going to be VLAN 100. And again, it's a number between 2 and 494. Technically, this goes from 1 to 496. VLAN 1 is usually what's called the default VLAN, which is every device is technically put on a VLAN when it's connected to the network. It's just the default VLAN, which is typically 1. So, and we can change the default VLAN, but that's a topic for another day. So this will be VLAN 1. This we're going to call VLAN 200. This we'll call VLAN 300. And this will be VLAN 400. Okay. All right. So now we've just created 4 separate networks. All right. And we got 3 minutes. I don't know if Jason has some, well, 3 minutes in my time, probably 3 minutes and 12 seconds less than your time. Or by the time you hear this, I should say. Okay. So now let's connect this guy to here. And so we're starting to build out this fantastic network. So I think we'll stop there. And 30 minutes is not a lot of time, I'm realizing. So maybe next week we do an hour. But what I'd like to do over the course of the next several weeks is start to build out this network. So first we're going to design it. We'll talk through how we think about networks and why we think about networks in specific ways. We'll strategize together on, the different components, and we can ask questions and understand sort of from the bottom layer all the way through to when we get to the hosting side and the configuration of things, how it all gets put together. So that's it for this stream, unless somebody has questions or ideas or feedback. And so what we'll do next week then is we'll take these VLANs and we'll start to, now that we talked about sort of the technically the physical layer, we'll start to talk about some of the other layers and build upon this basic network architecture. And if you come back next week and you have ideas on things that you think we should add to this network design, bring those ideas and we'll start to kind of crowdsource a good, secure home network design that everybody can eventually arm themselves in the event that they need to extract from this public cloud nightmare that we're about to all experience together. So I appreciate your time. Thank you very much for watching, and please comment, share if you think somebody might be interested in this. But I think that's the best way to go. We start at the beginning and let's build this network together so that everybody has a secure home network, a secure business network, and understands more on a conceptual level how all these things work. Thanks, and have a good one. Appreciate your time.